So in this module, we took a look at the server-side controls in ASP.NET. We talked about the HTML controls and the web controls, and how you can use those to build up your server-side logic and how they render to the client. Most importantly, we talked about how these controls retain their state across postbacks, so that anytime you place data into a server-side control, it intrinsically keeps that state as the page is posted back to itself. And that happens either because the control is an intrinsic postback element, an input element like a button or a input text element, or because the control explicitly taps into the ViewState repository. So the other thing we looked a lot at in this section was ViewState in general, how it's used by controls like labels and spans, etc., to keep their state retained across postbacks. We also hopefully gave you some indication of when ViewState can be detrimental. If you're using a lot of data binding in your controls, your ViewState field can grow very quickly, and that can increase the size of the request and response beyond what you would want for efficiency. So keep an eye on ViewState. Always keep an eye on it. Make sure it's not getting out of control. And we talked about a couple situations of where it's okay to disable ViewState and where it's probably not okay. The one big red flag where it's not okay is if you're handling the change notification event for one of the controls in ASP.NET, because those typically rely on ViewState to keep that, that notification event firing at the proper time. However, if you're dealing with a bunch of any of the data binding controls in ASP.NET, all of those controls use control state, which is the behavioral state repository that is added to ViewState but cannot be disabled. So you can freely disable ViewState in your data-bound controls and not worry about the behavior of those controls being affected. So in the last module, we had a chance to use some server-side controls in ASP.NET. We tried a little bit of data binding. We tried using a text box and a label and some other features. What I didn't have a chance to show you yet is the different categories of server-side controls that you can use. And there are fundamentally two categories, the first of which are the HTML controls, and the second of which are the web controls, which we have explored a little bit already. We haven't yet explored the HTML controls, however. So let's start here, the HTML controls. These are a collection of server-side controls that represent or give you server-side representation of client-side HTML elements. So whenever you take a standard HTML element on your page and mark it with the run@server attribute, and you can literally do this to any HTML element on your page. You can walk up to an anchor tag or an input element or an H3 tag or a span or a div, and you can put the run@server attribute on that control, give it an identifier, and then you have a server-side object with which you can interact with a control, change its content, handle events, etc. So it's a convenient way of manipulating server-side presentation, server-side element content, without significantly changing the markup. So one thing I've seen people use HTML controls for is if you have an existing HTML page that you want to programmatically modify the contents of, but you don't want to completely replace all of the elements with server-side ASP.NET web controls, you might consider marking some of the controls you want to manipulate with run@server, just the standard HTML controls, and that'll give you access to them on the server. So what I thought I might do to demonstrate this is go back to a demo that we'd been working with in the preceding module, where we had built up a page with a corresponding code behind page. And in the preceding module, we were just using a text editor and IIS to host it, but I'm going to switch over to using Visual Studio at this point. So I'm going to open it up as a website, and this will let me use Visual Studio's built-in ASP.NET server, the ASP.NET development server, so it's not actually going to be running inside of IIS for this simple test that we're going to do. So here's that page that I was talking about, the page with the corresponding code behind. And what I thought I would do is show you how to use an HTML control to get rid of this inline code markup that we have right here. So the first step we can do, and again, you have many options. There's several ways of doing it, but one approach is to go to the server side, go to the client side HTML element and say run@server. Give it an ID, something you want to be able to refer to it with. So how about ID loc h3 for the location h3 element. And then I'm going to get rid of the dynamic content and leave just some placeholder text to indicate that there's going to be more there when this thing actually ends up rendering. And then let's go to our code behind class. Now what this means is my server-side class should now have a member variable of whose name is underscore loch3 and whose type we don't know yet, I'll show you in a second, but whose type is going to give us access to properties of this HTML element, in this case in H3. So let's go ahead and open up the code behind and go into our load event handler and try manipulating that H3 element. So I'm going to say loc H3, and let me pause here for a second. Notice that as I hover over that control, it's telling me what type the class is. So here it's saying that's system.web.ui.html control.html generic control. And it turns out the generic control right here is one that's used for a whole collection of HTML elements in the client. So things that are sort of nondescript with respect to their server-side properties. So divs and spans and H3, H2, H1, etc., and a header. All of these are represented on the server by the HTML generic control class, and you'll interact with them in much the same way. So let's go ahead and try that out. I'm going to say loc H3 dot, and then notice I have access to the inner HTML and inner text properties, very similar to the client-side properties. And let's go ahead and set the inner text equal to I was loaded from, and then we're going to pass in the call to get type, extracting the assembly, and extracting the location of the assembly. So that's what we were doing before, but now I'm doing it in server-side code in my code behind and interacting with that HTML control that I marked as run at server in the markup. So here's the new H3 element. Let's go ahead and try running it. And if it works, we shouldn't see any change in the output. It should seem pretty much the same, and indeed it does. So that's good. Okay, so keep that in mind. You can use any client-side element. So I could mark this guy as an HTML element. I could mark the body as a run at server. I could mark the head as a run at server. And you can also use the HTML elements in the toolbox here if you want to. So I could place, for example, an input text element on the form, and I could go and mark this with run at equals server, and now I have access to an input element on the server side in my server-side markup or code. Again, most often you'll tend to reach for the web controls, so you probably wouldn't start with an input element from to begin with. You'd more likely start with a text box. But if you already have HTML controls or HTML elements on the page, and it makes sense to mark them with run at server so you can manipulate them on the server, perfectly reasonable thing to do, and you might consider it. The other category of server-side controls in ASP.NET is the web controls category, and these are all controls that are defined in the system.web.ui.webcontrols namespace. And these are an alternative to using these server-side HTML controls, and you're really pushed towards using these controls. You'll find that most ASP.NET developers use these controls over their HTML counterparts, and the HTML counterparts are usually only used when you already have existing markup that you're trying to manipulate on the server. And one of the reasons is you'll find these controls listed as the standard controls at the top of your toolbox. So this will tend to be the first place you go to start laying out your pages. That's where you grab your text boxes and your buttons and your links, etc. And one of the reasons that these are a bit more convenient to work with is that they have more consistent property names. So unlike the HTML controls, which reflect the idiosyncratic nature of the property names in HTML, these are named consistently across the entire suite of controls. So if you want to set the text in a button control, it's just going to be the .text property. Same thing in the label. If you want to set the text in a label control, it's just the .text property. If you want to set the corresponding CSS class in any of these controls, it's going to be the CSS class property. So once you know how to use one control, you know how to use a lot of the same features in all of the other controls as well. And that's not quite the same as the HTML. For example, in HTML, if you were setting the text of a span element, you would need to use the inner text or inner HTML property. And if you were trying to set the text of a button or an input element, you would need to set the value property. So you have to be aware of the HTML property names as you work with those controls. And a lot of these web controls are simply replacements for HTML. So you'll notice many of them they only render as a single HTML element. So the button will render as an input, the label renders as a span, text box renders also as an input with the type set to text, hyperlink renders as an anchor tag, etc. So many of these are simple replacements for HTML. Others, however, are more complex, more compound renderings. So for example, the calendar control, there's no client-side HTML element called a calendar. So instead what they do is they give you this calendar control here, but when it renders, it actually renders as a table with a bunch of cells that are written with the days of the month in them, and the header with the entire name of the month at the top, etc. Similarly, the XML control is one that takes an XML document and an XSLT file and renders by applying the transform of the XSLT to the XML document. So there's a variety of controls, some of which are simple mappings onto HTML elements, others of which are more compound, more interesting implementations, more complex. So let's take a look at web controls here in our demo. Now we actually used quite a few web controls in the preceding module just to acquaint everyone with the fundamentals. So the bulleted list is an example of a web control that renders a standard ordered or unordered list. The panel is an element that renders as a server-side div. Label is an element that renders as a span. Button is an element that renders as an input element type equals button. So what we could do here, let's sort of finish cleaning up our page, is get rid of this response.write. And let's replace it with a label. Let's just use a standard label. In fact, I'm going to drop that panel out of there too. So here's a label. I'm going to set the ID of the label equal to item count label, since that's what it's going to display. And I can set the text through the text property here, or you can also set it as the inner content for the control. So there are a total of items, and we'll just print that dynamically on the server. And then let's also do something like changing the font. So font size, maybe we can set it to large to get it closer to what it was before. And now I should have a control on the server named item count label of type label, which we know renders as a span, and I should be able to modify its content. So let's go ahead and set the item count label dot text. Okay, so again, even though it renders as a span, the server-side property for the text is simply text. And we'll set this equal to whatever we used to be writing out via response.write. So that was total number of items, and we called item count to string, and I no longer need to terminate it because I'm setting the text internally. Okay, so that should set the label text exactly like it was before, except now it's going to be rendered as a span with a font size style attribute as part of its rendering. So let's go ahead and try running that. Okay, so there's my total number of items down here, equals 10, looks good. And just as another quick example of a compound web control, let's try putting a calendar on here. And notice when I run the calendar, and you see the entire rendering down below, let's go take a look at the source code. You'll notice that the rendering of the calendar is obviously not just a simple HTML element, right? It's this moderately complex collection of HTML elements encapsulated by a table with a bunch of rows and columns inside of it. So that's how you work with web controls. Tend to be a bit more intuitive and consistent naming conventions, and usually are where you go first to start building your ASP.NET pages. One of the first things you'll notice about server-side controls in ASP.NET is that they retain their state across postbacks. Now this is something that in, say, traditional ASP you would have to manage yourself. As part of the post processing on the server, you would have to retrieve the values from the post body and populate whatever controls should reflect those values as part of the response. Now this happens automatically in ASP.NET, and the sequence goes like this. You have the initial GET request for the page, and that GET request is going to initialize the server-side controls in the server-side page class with their default values, whatever was specified on the initial form. Then, if the user clicks on an element that generates a post request back to the same page, so for example, a button would do this. If the user clicked on a button to submit a request, this would generate a post message, and that message would be handled on the server. And when the server created the server-side page class, it would then initialize the value of the server-side controls with the corresponding values in the post body of the request that came back. And the end result is any changes that were made by the client in those controls in the web page will be reflected in the server-side controls, and hence they'll be there in the subsequent response issued from that post. So let me just walk you through the sequence here of what takes place in a standard ASP.NET page web form interaction. So we'll start off here with an initial GET request. So the first time a user visits a particular page, it will issue a GET request. And this particular page has a pair of server-side controls that I'm interested in. One is the name control, and one is the personality control. And the name is a text box, and the personality is a drop-down list. So when we do the initial rendering, we're going to render the text box as an input element, and the personality as a drop-down list with some predefined values. And at this point, the user sees a blank form, so nothing has been set to those values. And then the user interacts with the form, so selects a personality, types in a name, and then clicks on a submit button, which will generate a post request that goes back to the server. And in that post request will be included the values for the input elements on the client, which in this case include the name and the personality. And those will be sent back with their current values. And then on the server, the page instance, brand new page instance, will be created for the page 1 class. And its name and personality values will be initialized to the values retrieved in the post body. And then when the page is rendered back to the client, those values will still be in place. So what you would have had to do sort of by hand in other environments happens for you implicitly in ASP.NET because of this concept of control, server-side control, state retention. Now let's go ahead and try this out ourselves. I'm going to go create a new simple page here to do some testing, and let's just call it state. State is fine, state page. And to put some values in here, or something to see the interaction go on with, so let's say enter name, and I'm going to drop a text box in there. And let's change the ID of this to _name, so it's something that reflects what we expect. And then let's also put a button in, and the button is just going to be an enter button, and we'll specify enter as the text. And let's go ahead and add a handler for that. Actually, before I add a handler, let's go ahead and put a label down below so we can print something when the user is done entering the data. So message label, something very similar to what we've done before. And then what I'll do, and let's separate these with a carriage return. What I'll do is add a handler for the button and implement the message label.text equals hi there plus name.text. So we'll extract that information and print it into the label. But what I want to show you is how these values are going to be retained across the postback when the user clicks on this enter button. So let's go ahead and run this. And what I'm going to do is bring up a tracing tool, in this case Fiddler, which acts as a debugging proxy and will eject itself between my client and server in this case. Now, a little trick, if you're using Fiddler and you're testing in a local ASP.NET page like this running through Visual Studio, it won't by default pick up any traffic, but you can sort of get it to do so just by putting a period after the local host in the URL mapped onto your page, and that period will cause Fiddler to actually intercept the request and show you all the traffic going back and forth. So that's a nice quick way to get some feedback on what's going on. So let's go ahead and hit enter. Now here's the first request and response. I'm just going to show the raw request and raw response. And this is standard HTML. There's the GET request, and the response has all of the initial default values for our form as we'd expect. Now let's go ahead and do enter a name and press enter, and that showed the form submitting here. Notice the name we typed in stayed in the input element, and here's why that happened. If we go look at the actual request and response. So the request that came across was a post request, and as the body of the post request, it included all of the name value pairs for the input elements on the form, which included the text box name as well as the enter button in this case. And then the response had those values reflected, right? The default value of the text box down here, as you see, was the name. And that was because on the server, when the page was constructed, it initialized the server-side controls with the values that corresponded to those controls in the post body. Okay, and that's why we have this state retention across post requests to the same page. I do like to point out this has nothing to do with ViewState at this point. You do see there is another hidden field here called ViewState, and we'll talk much more about that in a moment. But this standard state retention of input elements on a form actually does not use ViewState at all. This is purely about processing post-body variables and reinstating those values as the response is issued when the user posts the form. So we've seen that server-side controls retain their state across postbacks, and there are a couple implications to this. One is there's no need to reinitialize state in controls when you are processing postback requests. So if you're doing something on every single load event of a page and you're going back and grabbing data from a database or calling a web service or something, if you're taking that data and putting it into controls, there's no need to do that data retrieval on a postback, on a subsequent postback to the page, because the state is implicitly going to be retained for you across post requests. One other side effect of this is that you can't quite do cross-page posting like you might be used to in other environments in ASP.NET. Now, there is support for cross-page posting, as we'll see later when we get to the state management discussion. But by default, you can't just set the action of the form and expect that to work like it used to, because ASP.NET sort of takes control over that postback process and doesn't support the standard action setting that you might be used to. So we'll talk later about how to actually do cross-page posting if that's something you still want to do. One other quick note, and we're going to jump into this in much more detail in a moment, is that controls that are not intrinsically part of the postback, in part of the post body, the request, will still have their state retained, but it's through this other mechanism called ViewState. So if they're not an input control, say just a standard label, that will have its state retained via the hidden ViewState mechanism. So let's go ahead and take a look at the implications of state management here. And what I thought I would do is go back to our page that we looked at earlier, where we had a bulleted list that was being data bound, and we had a label and a calendar, and we had a button down below for performing a calculation. So what I want to do is take a look at the logic in our code behind class here and sort of identify logic that may be unnecessary or maybe being performed unnecessarily because the state is already retained in a postback. So the obvious place to look for this stuff is in the load event handler. And in this particular case, we're doing a manual data bind on the display list. And this is a good example of something that doesn't have to be done on postback requests, because the display list is going to have cached that data in its view state. Same thing with this location H3, that will also have cached in its server-side state. And same thing with this item count label. All of these things will have their state retained across postbacks. So one thing I can do to sort of optimize this is if we're not in a postback, which I can check by querying the isPostback property of the page, then we do the initialization. Otherwise, don't bother. Right? There's no reason to perform all of this state initialization on these controls if you're in the middle of a postback, because that state will have been retained from the previous values that were set in the initial get processing. So let's go ahead and try that just to make sure everything behaves as expected. So that was the initial get request, and everything looks good. Our items are complete. Our H3 is printing the right location, and the total number of items is printed properly down here. And let's go try doing a postback, which we know this add numbers button will do. And notice that this still has the location value, the items are still populated correctly, and the total item count is still correct as well. So all of that happened even though I didn't bother resetting the values as part of the post request. So keep that in mind as you're working with your pages, that you may be able to make some optimizations by leveraging the fact that the controls will keep their state across posts back to the same page. So the model of state retention for server-side controls is pretty straightforward when you're looking at controls that render as input elements that are sent back as part of the post request. Where it becomes less straightforward is when you are talking about controls that do not contribute anything to the post body as part of a post request. So this includes things like divs and spans and tables and anything else that doesn't contribute any information to the post body, and it's basically everything that's a non-input element. And the issue is, if ASP.NET is going to provide programmers with the concept of state retention for their controls across postbacks, it's sort of important that they do so across the board. So whether you have a label or a text box or a drop-down list, you can be assured that the state that was manipulated by the client or the state that was set initially is going to be there on the subsequent post back to the same page. So in order for this to work across all controls, we need a secondary mechanism for retaining that state. And that secondary mechanism is called ViewState. So ViewState is the additional hidden input element that is generated when each page is rendered, and it is used by controls to insert additional state that will be round-tripped as part of the postback. Now this is a very standard mechanism in web development, web programming, to create a hidden input field and populate it with state that you want to retrieve on the subsequent postback. So it's basically just a codification of that hidden field state retention mechanism into a more generic mechanism, which still relies on the hidden field, but the controls themselves will take care of populating that hidden field. And when you take a look at it, you'll notice that it is a base64 encoded string that's going to be storing that state. So to show you this, I thought I would start off with a small example here, just to keep it very simple and illustrative. So I'm going to create another web form. Let's call this one ViewState. And I'm just going to put a label onto this form, and let's give this label an identifier of underscore sum label. And I'm going to set the initial text to 0. Actually, not sum. Let's make it accumulator. So I basically want this thing to accumulate over time, add a value each time. And let's drop a button on to issue a post back. I really don't care about the button. It just has to issue a post back to the server. So let's go ahead into our code behind now and change the value of the label each time it comes back. So I'm going to do an int val is set equal to int dot parse of the accumulator label dot text. So we take whatever value is currently in there, and then we're going to set the accumulator dot text equal to val plus 1 dot toString. Okay, so we'll just increment it every time the request comes back. And I also want to do this only if we're not in a postback. So we check the isPostback flag, and if we're not in a postback, then we're going to, no, I'm sorry, I want to do this every time. So I'm going to actually do this every single time. So every time it comes back, I'm going to grab the value out of the accumulator, and I'm going to increment it, and then I'm going to set it back into the accumulator to whatever value it was before. Now, what we should notice is that the accumulator value is going to start off as 0, which is what I've set it to here in the markup. But then the question is, what will it be on a subsequent postback? So will it be the initial default value of 0, or is it going to be something reflecting what we actually made modifications to in the server previously? So let's go ahead and try running that. And notice that initially the value is 1. That's good. We expected that because it looked at 0, incremented it up 1, and then it got value of 1. And if I push it again, notice the value is now 2. So what we're seeing is that the state for that label control, which is rendered as a span, is going to be saved across requests back and forth to the server. Now, just to show you that the label itself is not part of the post body, let's go ahead and issue a new request here and go ahead and post the form. So here's the request that we just issued, looking at the raw request and response. So it was a post request, and the post body down here, notice it included the button as part of the input, but nothing else, right? There's no, well, there's a view state, but there's no representation for the accumulator control, and that's because it just renders as a span, and it's not naturally part of the post body. So in order for this thing to retain its state, it must have used some other field that was passed back via this post. And in fact, it did. It used this ViewState field. So that's what we're going to be looking at here, this ViewState field and how it persists values across postbacks for controls that do not intrinsically have their values sent back as part of the post request. So we've seen how ViewState is used as a secondary repository for controls that don't have their state intrinsically sent back as part of the post request. It's often useful to really go inspect the ViewState and take a look at what's inside of there if you're having troubles or if you're trying to figure out why it's so large or for some other reason. And there are a couple ways to do this. First of all, it is simply a base64 encoded string. So at the very least, you could grab any base64 encoder or decoder you have around and drop the ViewState string into that decoding, and it'll print out the string with the embedded links and such in it. It turns out, though, if you look a little more closely at the ViewState contents, it is actually a representation, a serialized representation of a tuple-based data structure. So it's a collection of doubles and triples and quads that sort of create this hierarchical collection of data into which all of these controls are placing their state. Now, if you're interested in decoding this in a bit more structural detail, I've built a ViewState decoder, is what I've called it, and you can download it from this URL right here. If you go to tinyurl.com/4dn377. And that will get you the ViewState decoder, and you can just open it up and paste ViewState into it or point it to a website and start taking a look at it. So let me just show you an example of using that. I'm going to go back to the website we were working on before and go ahead and run the state page. Or actually, let's run the bigger page, the one that had the bulleted list on it and the label and the text box and the button and all those other pieces. And if we run this page, I'm just going to copy the URL and then bring up the ViewState decoder. And there are two ways to use this utility. You can either paste the URL directly into this field here and hit the Extract ViewState button, which will reach into the requested page and pull out the value of the hidden ViewState field, at which point you can hit the decode option. And what I do for decoding is show you all the ViewState in its hierarchical relationships using a tree view, and that you can drill in and see the values of the inner HTML property for this particular element, for example, and sort of trace through. Or you could look at the raw text decoding, where it just uses hidden characters for the delineation characters, and I print those using the standard escape syntax. Or I also create my own XML format. So the ViewState is not stored in XML, let me be clear about that, but I have found it convenient in the past to actually just have an XML rendering of it, so it's easier to look at and potentially manipulate if I want to do so somehow. And you can sort of get a good idea of the structure of the ViewState by looking at this XML rendering. Now, the other way to use this is suppose we wanted to see what this page looked like, what the ViewState looked like after we had performed an addition down here. To do that, we could go and view the source of the page, and once you had the source, just go track down the ViewState field, which you can see right here. There's the hidden input field that contains the ViewState, and I'm just going to go select everything within the quotes of that ViewState input element, and go here and paste the value in, and then hit the decode option directly. So instead of having it extract the value itself, I will paste it in ourselves. And inside of here, you'll notice that we have all the values. Let's go to the XML actually. All the values that were saved during that post back, and they are set properly as well. Okay, so you might find that useful to inspect the contents of ViewState on your pages and get a sense for what's in there and how things are being stored. Now that we know what ViewState is, it's important to know how to turn it off, actually. Very often ViewState, you will find it to be useful. If you're dealing with small controls that don't have a lot of ViewState associated with them, it's a perfectly reasonable way to propagate state around a post-back request. But if you're dealing with controls, especially things like data-bound controls that can incur rather large amounts of ViewState, you want to be careful before you decide to leverage this state retention mechanism. And there are a couple ways of turning ViewState off. One way is by setting the enable ViewState flag to false in the page directive, and this will actually disable ViewState for the entire page. That's not something I typically recommend, just because it can have side effects on your page that you might not be aware of, or it can cause problems on the page. We'll show an example of exactly what types of problems might be caused if you disable ViewState in the next slide. So what I would recommend is identifying the controls on your page that you do not need the ViewState enabled for, and go into each of those controls and set enable ViewState to false. And in fact, I usually only make this optimization on controls that have significant amounts of ViewState that are adding to the bandwidth of the requests, and something you want to try to reduce. So let me show you an example. Let's go ahead and use a data-bound control and show you how much ViewState you could actually incur without potentially even realizing it. So I'm going to do a grid test here, and even though we haven't gone into real database data binding yet, I'm just going to throw a table on from a local database, the pubs database, and that will automatically generate a grid view for me, which we'll look at in much more detail in the data binding module. But what I just want to show you here is if I go ahead and run this page by using that data-bound control, the grid that renders all of the contents of that table to the page here, let's go see how much ViewState we're incurring by rendering all of that contents. So let's go ahead and turn on word wrap to emphasize the effect. And notice this chunk right here, this entire screen right now is ViewState, right? That whole field is the cache of data for that grid control. And this is a very easy thing to do in ASP.NET. It's very easy to sort of use these data-bound controls and have them just use their default behavior of retaining state across postbacks through the hidden ViewState field. And what you often end up with are large amounts of ViewState that is potentially not necessary, increasing the size of the requests going back and forth. So you do want to try to keep that in mind. In fact, let's go get a tab on exactly how much ViewState we're using. So down here you can see the character count. We're at 6592 for the total amount of ViewState characters. So what I'm going to do is go back and turn off ViewState on our grid and see how much we can save. So let's go ahead and locate the grid here. And you could set it over in the properties here, but I'm just going to type it in for safe simplicity. So enable ViewState equals false, like so. And let's go ahead and run this page one more time and take a look at, well, let's go ahead and use our decoder to see how much state there is. And extract it again. And notice we've dropped down from 6,000 something to 640. So that was a pretty significant reduction just by targeting the data-bound controls on our page, whose cache we weren't really using anyway. And we'll come back and talk more about data binding controls in ViewState when we get to the data binding discussion. But keep that in mind. If you are doing data bound controls, ViewState is one of the first things you want to check and monitor as you start working with your application, and probably one of the first things you want to turn off unless you can come up with a good reason for maintaining the ViewState in a data bound control. Now, I mentioned on the last slide that you want to try to minimize your use of ViewState where you're not really taking advantage of it. What I want to point out in this slide is an example of where you really do want to leave it on because it's fundamental in the behavior of your page to actually working the way you expect. And this is related to change notification events in server-side controls in ASP.NET. And change notification events are in things like the text box control and the drop-down list. And what you get is you receive a notification whenever the contents of that control has changed between postbacks to the same page. And the reason it's important to leave ViewState on for those controls is the detection of the change notification is actually managed through ViewState because they keep track of the prior value that was selected in ViewState to decide whether to issue the change notification event. So let me show you a concrete example of this and how it can sort of break the page unexpectedly if you're not looking for it. So let's do change notification.aspx. And what I'm going to do is drop in a drop-down list here. And I'm going to add some values to it. So let's add just 3 values and set the values to item 1, item 2, and item 3. And then what I'm going to do is add a server-side change notification event for this drop-down list. So every time we get a post back, if the previous value of this drop-down is different from the current value, it should fire this change notification event. So here's my change notification event, and just to print that information out, let's put a label down here, and we'll set the label text whenever this event fires. So we're going to say label1.text equals you selected, and we'll print out the drop-down list 1.selected value. So whatever is currently selected. Okay, so we'll do that. And then let's go ahead and put a button on the form to generate a post back. So that will give us the chance to change the value and then submit the form. You could actually set the auto post back property on this control directly, which would inject a little JavaScript to initiate a post back every time you change the event. But I want to show you this sort of subtle behavior before we venture further. So let's just try running with ViewState enabled so we see that everything works as expected. Okay, so I'm in item 1, I go to item 2, it says, hey, you selected item 2. Let's go down here, item 3, you selected 3. Let's go back to 1, you selected 1. Okay, great. Looks like what we expect. And again, this label is being changed only when the server-side notification event is fired. So if I click on it right now, the server-side event wasn't fired, but this label just kept its previous value in ViewState, so it works regardless. Okay, so let's go and disable ViewState on this control now. So enable ViewState equals false on the drop-down list. And what I want to show you is a subtle behavior. So let's go ahead and switch to item 2, click on the server-side post back, and we get the change notification. Okay, good. Now let's go back and select item 1 and click on the button, and if it is behaving as it should, this should go back to item 1 just like it did before, right? We click on it, notice it did not go back to item 1. So this is an example of one of the subtle behaviors you can run into if you sort of blindly disable ViewState on your page. And the subtle behavior we are running into here is this drop-down list doesn't use ViewState to keep the current selected item because that's actually part of the post body already as it's an input element, but rather it uses it to store the previous value. And if you turn off ViewState, what it will do is simply default the previous value to the first item in the list. So again, watch this behavior. If I go select item 1 and click it, I get no notification because it assumed the previous value was item 1 because it just defaulted to the first value in the list. If I go to item 3 and click it, notice it does drop me to item 3, and the reason for that is we got back to the server and it changed from item, the currently selected item was 3, and that was different from the prior item which had defaulted to the first item, 0. So subtle issues in your selection logic if you're not careful. So my general rule of thumb is anytime you're adding change notification event handlers like we have here, the selected index changed event, be careful not to disable ViewState on that control, because it can lead to issues like the one that we saw here. So, and also an item like this probably is not going to have much ViewState in general, so I would focus more on controls that have larger amounts of ViewState when you're doing your optimization, and that will keep you in safer territory. There is one other mechanism that's used for determining which server-side control actually initiated a post request. And this is the event target field, and it has a corresponding event argument field. And these are another pair of hidden input elements, much like the ViewState hidden input element. But I want to be clear about how these are used and when they're used. They're not used for standard postbacks with elements, input elements. So like a button control or an image button, these always render as input elements of type button or image, which will have their values sent back as part of the post intrinsically. So we can identify which control issued that post request. However, there are some controls that can generate post requests, postbacks, which are not traditional postback elements. For example, the change notification that we just looked at in the drop-down list, if you enable auto postback to be true, that will initiate a postback whenever you change it on the client side, and there will be nothing sent in the post body to indicate that the drop-down list was the entity which issued the postback. Similarly, a link button, which is an example of just an anchor tag in the client, but it's got some JavaScript to initiate a postback as well. That also will not, by default, alter the postback. So there would be no way for ASP.NET to know that the anchor tag was the thing that initiated the postback. So that's why there are these two other fields, the event target field, as we'll see, and the event argument field for storing parameters. And the event target field will simply store the identifier of the control that issued the event. So if you have a link button, the identifier will be stored there. Now let's go ahead and just walk through this. I want to make sure everyone's clear on why we need these supplemental fields. So let's go ahead and create a new web form to do some testing. And let's call this event target. And what I'm going to do is start off by designing a form with just a pair of traditional buttons on it. So standard server-side buttons that render as input type equals button elements on the client. And as I mentioned, these are not necessary. These will already send back their identifier when a postback is made, so we don't need to use that hidden field. Let me turn off ViewState on my label so it doesn't retain state across postbacks, and let me set the text of each of these buttons to 1 and 2 so we can identify them. And here's what I'm going to do. I'm going to add a handler for each of these button controls. So there's the first button click event, and here's the second button click event. And inside of the handler, I'm going to set the text of the label I put in below there just to a message. So you pressed button 1, for example. And down below we'll do the same thing, except we'll indicate button 2. Okay, so that's the idea. Let's go ahead and run this. And what I want to do is set up a trace so we can see the request going back and forth. So I'll bring up Fiddler here, and let's use our trick of putting a dot after localhost so that the traffic is captured. Okay, let's go ahead and press on button 1 now. So I got my message as expected, and here's the request in Fiddler. Let's bring up the raw request and response. And we can see how ASP.NET could identify that button 1 was the control that was pressed, because if you look, let's scroll in here, if you look at the post body, you'll see down here that button 1 was sent back with its value. And notice button 2 is not in the post body. So this is just the way HTML works and how post requests are generated from a page. And if you look at the source for the page here, you'll see those two buttons were rendered as input elements with type set to submit, and the value was just propagated back as part of the post body. So it's very easy to identify which control issued the post back when you're dealing with standard input elements. So here's an example of button 2 being used to send back the post request. Okay, so that nothing special is required there. ASP.NET can handle that. Easy to identify which controls. So let's take an example of controls that do not. Let's add an example of controls that do not intrinsically send back post body data, so that we could use that to identify which control issued the request. So one example of those that type of control is the link button, and let's just say link button 3 here. And I'm going to go ahead and add a handler for that and print the same message we did before, except let's call it link button 3. And then let me add one more control that will require similar additions to identify. Whoops, let me get it in the right place. So let's put a list box in. I could also put a drop-down list in. And let's go ahead and enable the auto post back, so that whenever the user changes the selection of an item, the currently selected item, it will issue a new post back. And then I'm going to add some items here. So item 1, item 2, and item 3. Okay, and then we're going to add a handler for the change notification event of this list box just by double-clicking it. And I'm going to say here, you, instead of pressed, selected a new list box item. Okay, so that should be good. Let's go ahead and just try running it so we can see the behavior. So now my buttons still work as expected, but now also I have this link button, which we know renders as an anchor tag, but it has a little bit of extra JavaScript to initiate a post back. And my change notification is not doing what I expected. Let's go check that guy. So we selected a new list box item. Post back is going back. Okay, everything looks okay. Let's just try that one more time. So try selecting an item in the list box. Good. Okay, so there's the selected item in the list box. There's the link button, and there are the button 1 and 2. So let's put a trace on this thing. So go up and put our dot in here. And let's go ahead and click on a list box item and see what the traffic looked like for that last request. And scroll down here and notice the event target. Let's zoom in here. The hidden event target field, which you see right here, was set to list box 1. So that was the identifier of the control that issued the postback. And you can see how that postback was issued. If you look at the source code for the page, scroll down here, here's the list box. It turned into a select element. And the onChange event handler was wired up to a client-side JavaScript event handler, which initiated the postback by calling this helper function do postback. So that's sort of a out-of-band postback technique. And notice the same thing happens up above here. The anchor tag, the link button, is also going to initiate the do postback by invoking that JavaScript function. So that's why we need the assistance. Let's go ahead and try the link button example, just to make sure we see something very similar. And indeed we do. So this time the link button was the item that was placed in the event target field. Okay, so those two hidden fields are used whenever you use any of these controls that generate a postback but are not traditional postback input elements in HTML. There is one other feature I would like to discuss relating to ViewState, and that is control state. So control state was a feature that was added with the 2.0 release of ASP.NET. And the goal behind control state is to give control developers another state repository in addition to ViewState that cannot be disabled. And this was the motivation behind this was many of the data binding controls in ASP.NET 1 and earlier, or 1.1 and earlier, sort of broke when you turned off ViewState. For example, the data grid. If you ever used the data grid in version ASP.NET 1, and you enabled the sorting feature and the editing feature, if you turned off ViewState, none of those commands would be sent back to the server properly. So they decided they wanted to enable or keep the behavior from working properly and still let people disable ViewState. So what we have now is this concept of control state, and control state lets developers distinguish between behavioral state and just the traditional state which is maintained across the postback. So the idea is to place your behavioral state into control state and then your standard state back into the standard view state. And the user cannot turn off control state. Now let me be clear about what control state is. It's not a separate hidden field. You won't see another hidden field on your form called control state, but rather it is just an appended collection of data to the view state field, which you cannot disable. So the end result is you can safely disable view state on controls that use control state. And what are those controls? Well, all the newer, in fact, all of the data-bound controls, which are the ones that tend to contribute the most to view state anyway, properly utilize control state for the behavior. So you don't have to worry about turning view state on or off with those controls. Everything will still work fine. So let me show you a demonstration of this just to be clear about what we're talking about. Now we have the grid that I showed you as a short example earlier. Let's go ahead and turn on some of the features that would require control state. So pagination, sorting, and editing. And we'll look at all these features in much more detail later. But for right now, notice that my view state is enabled. And let's just try running it so we can see the behavior of those features. So notice I can sort the author's table, I can paginate, and I can perform editing. So all that works fine. Now the test is going to be what happens if we disable view state. So I go ahead and find the enable view state, set it to false, and let's go ahead and run that again. And now because the grid view actually stores that behavioral state in control state, all my functionality is still in place. And if you want to take a look at that, let's go ahead and pull out the view state here and bring up my decoder, and we can paste that in. And notice I have down at the bottom right here a decoding of the control state. So you can actually see the control state in this decoder. And all I do when I parse the view state is look for the supplemental collection of data that's at the bottom. So notice because we disabled the view state, there's very little view state up here. It's just a single identifier for the page. Whereas the control state, let's look at the XML rendering so we can see the relationships. The control state actually stores a fair amount of data. One of the most important things the grid will store are the values of the primary keys so that it can properly send back notification events about editing and deleting and that type of thing. So that's most of what you see here. But it will also keep track of the sort direction on a particular column, among other things. So that's the control state. A piece that you cannot disable. It's a secondary part of the view state field, and it's used by controls to store their behavioral state so that disabling view state for optimization purposes does not break the control behavior. The last thing I'd like to point out is that you can use ViewState yourself if you find it useful to retain state across a postback to the same page. So it's just another repository of data that's going to be round-tripped in this hidden field, the ViewState hidden field. And what you can do is actually just drop pretty much any .NET object in there. Obviously you can drop primitives like integers and strings, etc. But you can also drop more complex things like lists of objects or custom class definitions or instances of classes that you might have created. The only constraint is anything you place into ViewState must be serializable, because what will happen is ASP.NET will take the instance of the class that you pass in, serialize it into a binary form, and then base64 encode the binary data for your controls. And the way you access this is by going into, or just accessing the ViewState property on your page. And this just taps into the existing collection of ViewState, and you can augment it with whatever data you find useful. So let me show you an example of using ViewState. explicitly. Let's go ahead and add a new page here to do some testing with and call it Use ViewState. And what I thought I might do is go back to our example where we had a list box that was posting back. And what I thought I'd do is just keep track of how many times the user has clicked on the list box, so that and we'll keep that information in ViewState. So let's go ahead and add a handler for this list box change notification, list box, and let's also put a label here. So I'm going to print out how many times the user has clicked or selected an item in the list box, and let's set it initially to 0. And let's also go prefix the label with you clicked the list box times. Okay, so we're just going to replace that 0. And back in our code, what I want to do is every time the user clicks on this list box is go modify a value in ViewState. Now, one technique I like to use is to create a property definition, which I'm going to do using the little code snippet here, prop. And I'm going to expose it as an integer. I want to keep track of how many times the user's clicked. And let's call it list box click count, maybe. And let's go ahead and implement this. And the way I'm going to implement it is by storing the count in ViewState as opposed to mapping it onto a local member variable of the class. So one other thing I like to do when I'm using strings to store ViewState is define those strings up here somewhere as a constant so that I don't mistakenly type the wrong string when I'm trying to retrieve it later. So let's just call this list box click count. You can come up with whatever string indexing mechanism you like for retrieving data from ViewState. It's always going to be scoped by your page, so you don't have to worry about clashing with other elements. Okay, so I'm going to return. You always want to see if it's actually in there or not. So let's cast the result to an integer, and I'm going to go access ViewState indexed by my LBCC string. And if that's null, I want to send back 0 for the default value. If you haven't seen this operator before, this simply says if this entity here is null, return this. If it's not null, return whatever's in here. And then I'm just casting the result to an integer to send it back as the proper value. And for the set, I'm just going to say ViewState indexed by LBCC is equal to the value that was passed in. Okay, then what we can do is we can increment the value just by using a post increment operator here. And then we can print out the value by saying label 1.text is equal to listboxCount.toString. Okay, so every time the user clicks on the list box, we're going to increment the value in our ViewState, and that will be round-tripped back to the client. So when the page is posted again, that click event, or that click count, will be sent back and reinstated in this ViewState field. So when I pull it out, it will have the incremented value. So let's go ahead and try running that, see the behavior, if the behavior works the way we expect. 1, 2, 3, 4, looks good. And let's just take a look at the ViewState field. So once you've done this, you should be able to go inspect the ViewState and take a look at the custom content that you placed in there. And in fact, we see it right here at the top. The current list box click count is set to 7. So any custom data you would place in here would be dropped into a name value collection like this. And again, this value would be serialized state for your class or whatever you ended up dropping in there. So keep that in mind as you're thinking about state management in your ASP.NET applications. The ViewState repository is always at your disposal. Controls use it for their own state, and you're welcome to use it too. Just beware that it is going to be round-tripped. So unlike something like session state, which stays on the server, this is going to be part of the request response stream. So it's a good replacement for things you might have done in the past using hidden fields. It gives you a nice, strongly typed way of achieving the same type of functionality. Hi, this is Fritz Onion with Pluralsight, and we're going to be looking next at the control-based programming model in ASP.NET. Now, specifically what I want to look at here is how controls interact with state on the server. So we're going to start off with a look at the difference between web controls and HTML controls, both of which are different categories of server-side controls in ASP.NET. Talk about when you might want to use each one and what purposes they serve and what sort of overlap there is between the two class hierarchies. And then we'll turn our attention to state management. So how do controls maintain their state across postbacks in an ASP.NET page? And as we'll see, this is really one of the critical things you need to understand as you start working with ASP.NET and building ASP.NET pages. We had a brief introduction to server-side controls in our introductory module, and here we're going to spend more time really understanding how that state is managed and how you can influence the management of that state. So we'll talk about the state management. We'll also talk specifically about ViewState, which is a hidden field that can be used to transmit additional state information across postback requests, and most controls use it up to a certain extent. And we'll also touch on one of the newer features of ASP.NET that was released in version 2 called control state. And this is distinct from ViewState and gives controls another repository which is similar in concept to ViewState, but is different in the sense that users are not allowed to turn it off. So it's used primarily to store behavioral state. So that's our goal here, to really understand the server-side control model and state management in ASP.NET pages.